If you are at the point in an Algebra II course where you are multiplying polynomials together, it is likely that you have some experience with multiplying binomials. One of the major core lessons and ideas of Algebra 1 is being able to multiply expressions that look like this. Now, it's possible when you learned how to do this, you learned how to FOIL, where you multiply the first terms, the outer terms, the inner terms, and the last terms, Or it's possible that you learned how to answer this question through the distributive property. As expressions get larger and there's more terms part of every polynomial, the distributive property ends up being an easier route to take. You break down one of the polynomials and you multiply it individually by the other. If you wanted to try to engage a FOIL kind of strategy with this question, there would be 6 different multiplications that you would have to make. You're still going to make the same 6 multiplications, but keeping track of which ones did I do, which ones did I not do, becomes much harder as you up the number of terms. Because x plus 3 has only 2 terms, that's going to be the polynomial that we break down. We're going to say that the first term of that polynomial needs multiplied by everything in the second polynomial, and the second term of the first polynomial, namely the 3, needs multiplied by everything in the second polynomial. Still serves the same function, is going to get all 6 of those multiplications, 2 terms from the first polynomial, 3 terms from the second one, but it's going to do it in an organized fashion that's going to make it a little bit easier to make sure you got everything. So next step is just multiplying the first by x, so everybody's power of x goes up by 1, and then multiplying the second one by 3. Everybody's power of x stays the same, everybody's just 3 times as much. So we have these individual terms correspond thanks to each of their multiplications, and then we just start combining what we can combine. So I see a negative 9x and a 15x that I can combine. That's going to make 6x, but it looks like there's nothing else, and that's okay. That's not completely out of the ordinary that you would end up with something that doesn't have a lot of simplifications to it. It's not completely strange that would happen. 3x to the 4th plus 9x cubed. We are going to try to write it in standard form where we go highest power to lowest power. And then the combination of those two is our x term, followed by minus 27. So while we end up with an answer that has 5 individual terms in it, it came from a responsible path of multiplication that demonstrates an understanding of how this is supposed to work. Not the use of an acronym that, as the polynomials get longer, becomes that much harder to apply. So as long as you can identify the smaller of the 2 polynomials and break that one up, it makes the multiplications that much easier.